Hello, everyone. Welcome to the second day of the immutable and reproducible track. I hope now, I hope you had a great scale so far, and I've seen some of you at NixCon. So here we are. Las has come and graced us with his presence and talking about all about WASM on Nix. So without further ado, take it away, Las.
Thank you, thank you. So I'll begin my presentation. Does anyone know how to use WL Mirror? I no, this doesn't work, does it? This is what happens when you're not ready. But I'm almost ready. Yes. Okay, it works, great, great. I just wanted mirroring so I could see what I'm writing because I couldn't see what I'm writing. Great. I'm doing WASM, and I'll zoom in more for you all. In Nix, not Nix on WASM, but WASM in Nix. The idea is very simple. I assume you all know what Nix is. Does anyone not know what Nix is? Okay, thank you. Does anyone not know how derivations work? Okay. I'll go over derivations shortly. So Nix, you all know the language. But under Nix, there's another language called it doesn't have a name. I'll call it the derivation language. Derivations have an ad hoc syntax, basically recipes to describe what you want, how you want it. And I'll show an example, actually. I'll show an example. This is my shell, by the way. It's Haskell. Don't worry about that. I think it should work. Let's see if this works. This might be the magic and can't. No, it's not. You know, this never works. It always does some funny stuff. I'm not sure how to do this. There's a way of doing it. There's always a way of doing it. What do you mean right? There we go. I feel like every day I'm getting more stupid. Oh, I don't have a name. That's why it doesn't work. Why didn't no one tell me this? Oh, no system. Why do you need so many attributes? You know, this is the issue. This is actually this I'm fixing. I wonder if this works. This is actually exactly what I want. So you see, this works. I put in a random system, and it still works. And I'll show you the important part in a moment. Do you see that? You see this maybe? You see this? And we can even maybe JQ it. Can we JQ it? Do I have JQ? The syntax is wrong. This is a derivation. The actual on-disk store representation is kind of different, but this is the JSON representation. This is what Next actually is. It's not a, I mean, this is the language, but this is what actually happens underneath. You have a description of how to do something, what to pass the builder, and Nix figures out to build these in the correct order, caches them, substitutes them, does everything you want. Even Geeks, for example, Geeks uses this, but uses Lisp to make these. You could even use Bash theoretically to make these. There's no reason you couldn't do an X packages in bash where all the code is bash, and it would still work perfectly. The idea then here is, you see that system, that nasty system at the very bottom, and it's something random I made up. And normally it would be x86 64 Linux, it would be Arch 64 Linux, it would be Darwin, Windows in the future perhaps, hopefully not. It's very annoying. I mean, if any of you have ever tried using a Raspberry Pi, you have the issue that the same system, built on the same NixOS configuration, built in different systems, gives a different derivation. Thus, no caching. If you build your system, you have a Raspberry Pi, you build its NixOS configuration on your very powerful Threadripper, and you then try to rebuild it on your shitty Raspberry Pi. I don't know how many cores. Does it have 1 or 2 or 0? It won't be cached. You'll have to rebuild it all again. The goal of this is to fix that, to have one derivation to rule them all. The WASM derivation. Now, how does the WASM derivation work? The idea is very simple. What was the builder we did at just before? You see the builder? In this case, it's path. What is a path to? It's a path to a Linux executable, usually ELF. I think you could theoretically use some other things. But that's not portable. I mean, you can do the whole bin format thing, if any of you have done that, where you use QEMU to emulate another system, and that's usually what you should do actually if you're building for Raspberry Pi, because the Threadripper can afford to build using QEMU. The Raspberry Pi cannot afford to build x86 using QEMU. The idea is then, what if we supported WASM? What if we somehow had a WASM executable format which you could execute and which produced some kind of output? This would have a range of benefits, like IFD would work. Well, what does work mean? It can mean a lot of things. One of the things that doesn't work right now with IFD is IFD doesn't work when you have more than one system and use flakes. Because the issue is to create, does anyone not know what IFD is? Okay, that's a lot. IFD is short for import from derivation. I'll zoom this a bit out. It's basically when you do something like this. This doesn't give me syntax highlighting. I should have made my file a markdown file. I do this again. No, so it's when you do stuff like this. This is what IFD is. You have some derivation, you build it, and you import from it. You import what you've built, import from derivation. It's a great tool. The issue is, well, how do you build it? Well, you need the system. But what system do you use to build it? You have to predefine that. If you're using flakes, you have to define what system you're using to build the derivation for IFD. So you can't, for example, do Nix flake show. If you try to do Nix flake show, it won't work. It will work partially, and I think maybe there's a flag to ignore the things that don't work. But you'll have the issue that it can't show the entire flake, because some parts of the flake need IFD with a system that you don't have. You can set up a remote builder, kind of solves the issue, but it's not a good solution. But you have WASM. WASM works everywhere. Does anyone not know what WASM is actually? Okay, I'll explain WASM too. WASM is a stack machine. It doesn't matter that it's a stack machine actually. It could be anything. WASM it's basically an ISA. Does anyone not know what an ISA is? Okay. I'll use simpler words. WASM is a format to represent how to execute something. At its core, it's not really that different from another language. You could theoretically use JavaScript in WASM. It would be much worse, but you could theoretically. You could use anything instead of WASM. It would work, but worse. The idea of WASM is that it's fast and easy to compile performantly. That's the entire goal. It's an intermediate representation where you might write some code in Rust, or theoretically Bash, compile it to WASM, run everywhere. Originally it was for the web. That's why it's called WebAssembly. I prefer to call it WASM. But we can use it here too. And it works perfectly because one of the great things about WASM is that it has a defined execution model. It has semantics. It has a specification. And that means we have another problem solved for free. If you've ever used Nix, well, does anyone here not know what content addressed derivations is or are? Okay. Basically, Nix has something called content addressed derivations, also called CA derivations or CA. Idea is when you build something, you want to record its output. You want to record what it actually built. The issue is, which applies even if you don't use CA, the same derivation might be impure. It might result in many different outputs, depending on system paths. Because, for example, in the derivation we just made, imagine I do this. What about, and let me make this an actual working derivation. We do -c to execute a command. And what if I do ls CPU? I actually think I have ls CPU. What do I have? I have proc CPU info, don't I? Into out. This might very well not work. Oh yeah, my machine is R64, I forgot that. Cat is not found, of course. Is there a way to... Oh, I think I can do this. That's crazy. Who made Bash? And you see, this works. It works. And it's completely horrifying because the issue is it doesn't have an output. Oh, that's interesting. Yeah, you can do that. You can do that. But you could replace with something else, something that's actually impure. Imagine this output isn't empty for a second. You get a different result on different machines. You might, for example, record how many cores you have, how much memory you have, and you might record that in derivation output. The issue with this is that we want reproducible builds. That's the entire point of Nix. Reproducibility, immutability. You've heard these buzzwords, haven't you? Does anyone not understand why these buzzwords are important and not merely buzzwords? That's great. We all know why it's important. I don't. We want complete purity. Complete purity. No exceptions. Completely no exceptions. WASM is the tool to do that. Because you have a completely defined format, you have a defined specification, you know what is going to happen, and this kind of stuff, it can happen because you get a predefined amount of memory. Of course, the WASM module can ask for memory. It can ask, and maybe it's time to actually show what WASM looks like. So this is my sheet of code. I've been working on this for a few months now. This is the future of Nix, I hope. This is what the builder would look like in the future. So this is a WASM module defining the textual format called what or WAT. You can choose how you pronounce it. This example doesn't actually work right now because I haven't updated it. But imagine it does work. We have some imports, we have some memory. Can you see we ask for the memory? So the one here is a multiple of some amount, 65 kilobytes. 64 kilobytes, not 65. This has the same result on all machines. This is what I want. The same result on all machines. I want perfect caching. I want perfect reproducibility. And it also gives you free CA because it has perfect reproducibility. Another use for CA, which you might know, let me go back. Has anyone heard of TrustX? Okay, that's a few. TrustX, the idea is, well, You use the binary cache. You know what the binary cache is. Cache next as a dog. But how do you know it's actually, how do you know it's not compromised? The answer is you don't. You have no idea if it's compromised. The idea with trustics is that if you have multiple people building the same thing, and they all agree, well, then there's likely no issue. But if there's disagreement among the caches, there's an issue. But of course, how can you know if the disagreement is due to maliciousness or due to a software bug or rather impurity, if you don't use WASM? Because if you don't use WASM, it's very normal that you get different results. Everything is impure. Most builds are impure. Often you get the same result out of pure chance. Many times you don't. If you try any big build, if you try to build Chrome, if you try to build Firefox, you'll often get different result every time. And this is actually one of the reasons for why constant addressing isn't really viable right now, because you get too many different results too many times. WASM, you get that for free. It has many other great parts, though. Has anyone here heard of dynamic derivations? The fun thing about WASM is that it's kind of crippled in a good way. It's crippled in a good way. You can't do anything, but you can do much. Dynamic derivations is, I'll explain it simply. When you Nixify a project and you compile the project using Nix, you have one derivation for the whole project. This is not optimal though. You can get more fine-grained caching if you have many derivations for the project. One per source file, in fact, would be optimal. You could even go lower than that if you so desire, but that would be very impractical. With WASM, we also get that for free, almost free. This is one of the great reasons to use WASM derivations. Now, there are many challenges, however, in doing this, because nothing actually works in WASM. This is my biggest issue. And I've done the integration. It theoretically works. I haven't run the test yet. I hope it works. But have any of you actually tried compiling C code in WASM? What, you compiled C code in WASM? Using what website? Please tell me what website that is. Like, no, not compiling to WASM, compiling in WASM. That's the issue. All of the compilers, they support compiling to WASM, but none of them thought that maybe they should be able to compile in WASM. This is my issue. None of the compilers work in WASM, because some of them do. I think Rust works. Some of them, if you've seen some websites, some language websites, they have demos where they compile to WASM, and you can run it in the browser, and that's great. Please, what do you... Well, like the point, combining, it's the environment, right? When you're compiling in WASM, it means the compiler is itself running inside WASM. And that's the big difference. Because with this project, basically, you need to run everything inside WASM. You need to run make inside WASM. You need to run LDD, DCC, bash, all of these horrible things, which I would rather not touch. But now I have to touch them. I have to go through all of them one by one and make them compile to WASM. And it's not the whole story, actually, because what about stuff like pipes? What about Unix domain sockets? Stuff like forking. You can do forking inside WASM. I mean, you can make your own runtime. I don't want to make my own runtime. I don't want to do all that work. So to clarify, WASM runtime, code that does all the work to run WASM. Some of the runtime support it. I don't think any of them do it well. I just want to do this and get over with it, because it's useful, but there's a lot of work to do. But there's more we can do, actually. There's much more we can do with WASM. There's a reason why I'm doing all this hard work, which will likely take a year at least to even get something usable, because you can do tons of cool stuff with it. For example, what about reproducible GPU access in WASM? Or WASM, actually in NICs. Or for example, maybe you want to run NICs on your toaster. But your toaster, actually, if your toaster supports Linux, you can already do that. If your toaster doesn't support Linux, well, WASM works anywhere. You could even run NICs itself in the browser. You could do all the compilations in the browser. You could have a whole environment in your browser. You could have a whole OS in your browser and just use NICs. You could give sandbox support to device peripherals. You could give sandbox support to accelerators. You could give sandbox support to, you could give sandbox access to FPGAs. Because WASM is extensible. It's very easy to define an interface whereby the module can talk to the host, like I've actually done here. If you look at the example, the shit example I have right here, I've defined a log extension. There's a way for the module to log. And you could very much just add run Doom. That could, in fact, be something exposed to derivations. And you could do this in a user extensible manner, where the user has the choice of how to do these things. Yes, please. Yeah, something like that. You'd have to put in the system features, and you could do, optimally, I think you'd provide a path to a WASM module, which would do the access or something. And then that would have more access to the system. There's many ways you could do it. You could also do something platform specific. Yes. You have to trust that it's reproducible. It's like you give control to the user. So you shouldn't, if it's buggy, it's not going to be reproducible. But it should be reproducible, for example, if you do GPU access with WebGPU. Because WebGPU, the whole idea is it's sandboxed. And complete, perfect sandboxing implies purity. Because if it's impure, well, then you have leak in the sandbox. So ultimately, it should be reproducible perfectly. Of course, it won't always be, and you'll have to catch those edge cases. We can do crazy stuff, though. We can even do, does anyone know what ZK stuff is? Okay, a few know. So the idea is you use cryptography to prove correct execution. But you need a model. You need a model whereby you can say, okay, this is what the correct result is, this is what an incorrect result is. And x86 is extremely complicated. Many systems support RISC-V. And of course, you could actually, that's something you do. You could also support RISC-V derivations, but it wouldn't have all the same benefits because RISC-V isn't as easy to sandbox performantly. It is, however, much better than x86. The idea is then, given a WASM derivation, compile to RISC-V, prove execution, now, no possibility for malicious cache. That's all we want. We want security. We want the cache to not lie. One of the great reasons to do this. There's a great many things you can do with this, actually. Is anyone interested in hearing about how I actually did this? Or are there any requests for what to talk about? I'll go into the code, and please do mine. It's shitty. So Nix, where is it? So Nix has this huge file called derivation gold edge edge. I've trimmed it down. Basically, Nix has, I'll write it down. Nix has roughly 1 goal per derivation. Goal is straightforward. Goal is what you want to do. Goal class figures out how to do it. roughly. I've added code to, and please don't mind, the code is very shitty. I've added code to run WASM modules. Unfortunately, how do you actually use WASM? It turns out most people talk about WASM but never actually use it. Because there isn't a way to use WASM reliably from C or C++. There's the so-called WASM C API. Unfortunately, it's unmaintained, unsupported, unused, and it's crap. It's very funny. It's an official WASM standard or something, I think. But there's literally, I think there's one implementation. I think the spec might implement it, this spec implementation. But most of the implementations that aren't slow don't support it. They don't support any of the features. They support one or two of the features they need. They don't support any of the critical features they need. Most of the work is just dealing with bullshit like this. But if you have some WASM runtime that supports the subset of WASM C API you use, you can in fact load it. It's a setting. I'll actually show how to do this. I have a, what did I do? There we go. You can see I pass a huge path to a WASM engine. So you can use your own engine.
Do you really think that using zero-knowledge proofs to prove a WASM derivation is correct is something that will be possible in the foreseeable future?
Foreseeable future is it performant? Likely going to take some time. The latest result I know, it's roughly a slowdown of 4 or 5 orders of magnitude. So a build that would take 1 second is that's going to take 100,000 seconds. That's a long time, but if you have the patience, you can do it.
So, did you consider using for your runtime, the WAMR API directly or something instead of WASM C API?
Yeah, but I didn't want to fix myself to one runtime. And it turns out even with WASM time, even if you use the WASM time specific CPI, it still doesn't work. It doesn't support any of the features you need.
So I see a wasmtime.so there. So in that case, why don't you just link nix against wasmtime.so?
No, that is what I do, but it doesn't actually. So the issue is, if you look at the code, there's some of the. Okay, so this is ifh2, but so what you actually want to do is, I'm going to define a new built-in some sense. You do something, you have a function, and it takes an argument. But that argument, well, it's an external ref. What's an external ref? Well, an external ref is a value that is opaque to the WASM module. The host can put in whatever it likes, and then this is what you'd use for basically any interaction with the host system. So for example, you might have an open import. It's somewhat equivalent to a syscall, if you know what a syscall is. And of course, I think it's called results, yes, or the result. It would return an extern ref, which is, it's somewhat like a file descriptor, actually. This is extern ref is the equivalent of a file descriptor in the Linux world or POSIX world. The issue is WASM time doesn't support this, and that's the critical feature I need. I'm going to have to support it myself, I think. There are workarounds, but the workarounds, they don't. So the workaround you can do is you can do the Linux FD trick, where you have integers that refer to what you want instead of opaque values. But the question is, how do you allocate those integers? Because you need to do that in a reproducible manner that is stable across time and implementations. That's the issue. None of the runtimes support that, basically.
Hello? Yeah, if you go to bolt.tvix.dev, they actually have a demo of WebAssembly Nix evaluation if you want to check it out.
Yeah, I actually heard about that, but that's only the evaluator, isn't it?
Yeah,
Maybe
it's
maybe
just the
does it do derivations? What's it called?
Bolt, B-O-L-T, .tvix, T-V-I-X, .dev, D-E-V,
Bolt dot
tvix,
tvix.
T-V-I-X,
So-
.dev.
Is it correct?
Yes.
Well, we'll see what they have. This is cool, actually. I imagine you could also compile the Nix language library called libexpr, I think, to WASM trivially. The hard part is actually doing something with it. Does it work? Well, then what? It's still cool. It's still cool. I won't say anything bad about it.
Laz, how long have you been working on this?
Man hours?
Yeah.
Too much time. Most of my time is half my time has been spent writing code. No, a fourth of my time has been spending writing code. A third of my time has been spent understanding Nix. The other third has been understanding how to actually do this thing. And what does that add up to? I can't do math. A third, a fourth. Okay, thank you. And the final 112 has been scratching my ass. Well, I think in total like a couple hundred hours, something like that.
All right. Yeah. Thanks.
How do you actually like spell WASM? Like,
What do you mean?
well, I think you showed me once before. You have a special way of writing it.
Oh yeah, no, that's the IPA. So the
Can you
trick
show
is you. I can't write it with this keyboard, but it's something like where. And then can we do this? No, it's it's IPA. If you know IPA, you can do this. Where. Zoom. And then you have this. That's how I pronounce it. I pronounce it this way because it's what I feel is right. Anything else would be disjustice to WASM.
Have you looked at all into the WASX API that does support opening, forking, all those kinds of things? The WASMer runtime?
So I mean, this is an interface. So there's WASX, the interface, which isn't actually useful to us, which I can explain. And WASM does support forking, but then you'd have to bind Nix users to WASM. And I mean, the thing with Nix is that it's supposed to be bootstrappable trivially, because it should build everything else. And if you depend on a single WASM library, WASM, which I don't think they've thought anything about bootstrapability. That really ruins the bootstrapability of Nix. With this, you have the option of using the reference implementation, which is I think it's OCaml or something. I'm sure there are a bunch of C implementations, the bash implementations, so you have a much better story for that. But the part about the WASX, why not use WASX, is because actually I have an MD file with the documentation. I don't know, why does it go? I have this in experimental features at C, which explains how it works. But I have an interface specific to this. And the question is, why have an ad hoc interface? Well, because it's not actually much harder, and it gives you much more features. The question is, because WASM doesn't just have fork, it has a bunch of other things. Like it has connect, I imagine. It has directory functionality. But does a derivation actually need directory functionality? The answer is no. Derivation does not need directories. It doesn't even need anything beyond the ability to add to the store. And that's another thing. WASM derivations, I decided to do it only CA, it's constant addressing, because it doesn't make sense to do anything else. So input addressing is the old scheme whereby the output, I'll write this out. Input addressing. Output path determined by derived path, roughly. With constant addressing, output path determined by output constants, roughly. WASM derivations does only this because it makes more sense. That's also why it's much more similar. One of the great benefits about this is that all the code to build WASM derivations is, I think it's 10 times smaller than the code to do the native building, which is a bunch of horrible code. I mean, it's horrible not because horrible people wrote it. I mean, they might be horrible, I don't think so. It's horrible because features have been added on without cleaning it up. And you see, so really the only thing you need, and this is very hard to read because it's all green. I think I can make this black and white. Yeah, there you go, there you go. You have the add functionality, and you have the output functionality. And that's basically everything you need. And there's exit and fail and stuff like that, and there's log. But that's the only things you really need. And there are files, but the files aren't really files. They are ways of basically expanding your memory, because you might not have enough space in memory. I mean, you might be creating an intermediate 1 terabyte file in your derivation, and you don't want to do that in RAM. Please, Matthew.
Yeah, you're right about the bootstrapability, by the way. Mscripton requires 4 languages to build a C file into a WASM module.
Can you say that with the mic isn't on, and my hearing is bad.
Oh, my bad. You're right about bootstrapability.
I don't think it's on yet. My hearing is just bad then.
Yeah, there we go. You're right about bootstrapability because Mscripton requires Node, Python, Java, and a C++ compiler to build a C module, which is horrible. It is, I mean, great piece of software, but goodness gracious. But at the very beginning of the talk, you mentioned that this talk was about including WASM modules within Nix.
Yeah.
But then you gave at the end an example of running a Nix module in the browser, which is Nix in WASM. So would you say that both are valuable?
I mean, both of it. That was just Matthew that pointed that out. It's useful in its own right, running Nix in WASM. But you can't really run Nix in WASM if Nix doesn't run WASM. Because Nix runs code, and how are you going to run code in WASM if it doesn't support WASM? So you need both to run Nix in the browser, really. If you just want to do the language part, which twigs it, that's trivial, completely trivial. But if you want to actually build, for example, Firefox, if you want to build, the thing Matthew made, the Nix to the Planet micros thing in the browser, you need WASM. You need this feature. And the point about Mscripton, I completely agree with that, but I could also rant about Mscripton for 10 hours, merely because of its name. It should be Nscripton. The thing is, when you have the in before the scripton, it doesn't turn into an M. It only turns into an M if the consonant following that is labial. S is not labial. S is a sibilant. It's a dental sibilant. Almost dental. Alveolar. It should be Nscripton. I hate it. I hate Mscripton. I hate the software. It shouldn't exist. And this is the issue with WASM, really. The tooling is horrible. Nothing works. But it's useful. It's useful, and that's the idea. Just I have to do all of the tooling myself. Not all of it, but a good part of it. There's a lot of work to do. Truly a lot of work to do.
So if this were perfectly implemented and done tomorrow, would I have to change the way that I write derivations, and would it change fundamentally the way that Nix packages works? Or can people just do what they're currently doing and get all of this for free?
Yes and no. You can choose not to change it, but that would make it very slow because you'd have to emulate a full POSIX system in WASM. And you could do that. there's no reason you can't do that, but that would mean interpreting code in WASM, interpreting, some binary format, which is of course much slower. Because many derivations also depend on forking, they depend on pipes, they depend on many features which don't really work well. They depend. Another big one is, for example, running executable. Because when you have a derivation, you do GCC x.c, and you put into out. But you can't do this in WASM. Well, because you can't actually execute anything. One of the many issues. Why can't you execute anything? Because you can't do JIT compilation. When you're trying to load GCC, it needs to load the code. You can't load code in WASM. From a CPU perspective, this is actually JIT compilation because you're loading code dynamically, and this doesn't work. You need to do a bunch of stuff to make this work. I mean, this is why something like dynamic recursive next dynamic derivation is needed, because you need to essentially make a derivation per call to another executable to do this. And that's one of the many issues. So you'd have to rewrite much of Nix packages to make you full use of it, but Nix packages isn't that good anyway. I wouldn't mind losing it.
I've seen that people use WASM to execute things like QEMU in JavaScript in the browser.
Yeah, you could do that. There's like Blink. Blink is great. You could do Blink for the things that don't work well.
Right, so you could use Blink to execute a RISC-V machine, which then runs all of these POSIX things.
Yes, yes. I'm also thought you could do a RISC-V to WASM compiler maybe, which would also be great. But that still wouldn't support JIT compilation. You could add JIT compilation, but that's like another 1-2 year project. I don't have that much time.
So to carry on what Matt was saying, what do we need to do to change to get it to work with WASM, our derivations?
I mean, ideally, you wouldn't need to change much. Ideally, it would just work, right? But there are things that wouldn't work. You'd have to change the base libraries. You'd have to change standard M to work with it. You'd have to change build Rust module. But the code most people write should just work. Because most people don't do forking inside a process. They don't use multithreading inside a process, inside a builder, which is the hard part. That's the thing you need to avoid. Calling out to things that need to call back in a dynamic manner. So if you have two processes that talk together constantly, that doesn't work. One-way communication works well. Two-way communication doesn't work well. I mean, maybe you should repeat the question so it's recorded or something.
So you said you don't have to. You said you don't have to change much, but I mean you have to completely rewrite your derivations in WASM, right? Unless we have a way to compile pretty much standard env to WASM.
Yeah, that's the idea.
But you said you don't have that.
I haven't
you
done
need
it
a sort
yet.
of POSIX layer, right?
I mean, I think you'd have like a semi-POSIX layer. You'd implement a subset of POSIX that works well with this, and it would be performant. It's this subset. It's what's outside the subset, which is problematic, and is what you need to change, like forking, piping, stuff like that.
Right, but I mean you need that. You cannot do anything without forking.
You can get around it. That's the point. Like that's why you. So the trick is when you do this call, instead of forking and doing so the way you execute something in Linux or POSIX is you do a fork and then you do an exec VE or something. So you fork, you clone your current process, and then the clone process replaces itself with another executable. The way you do this in WASM is you create a derivation. Inside the derivation, recursive next, that runs GCC. You'd build this from inside the derivation and read the output. So that's what you replace forking with. And that works for many cases, but not bidirectional communication cases.
Any more questions? Any other content loss you want to talk about?
You know, I always forget what to talk about. I think I had a list, and I forgot to talk about it. I think actually I have a list. Let me see. Yeah, I have a presentation. I think I talked about most of this. I wrote a derivation. I wrote a presentation and forgot about it. Don't worry about it. I think I talked about everything here. Yeah, I talked about everything. Yeah. The Clippy. Oh, that's Kakon. You see this? That's Clippy. It basically. I don't know what it does. It's just looking at me every day. You just install Kakon. It's part of Kakon. CAC. It's a French-Canadian editor. It's like Helix but better. Helix was supposed to be like Kakon but better, but they failed. So just use Kakon. Please.
I believe the question is, why do you use Haskell for your shell?
That's a good question. I have a blog post about it. And there are better ways of doing this now. I need to upgrade to the better way. Originally, I don't have I deleted it from my computer, I think. Actually, I still have it, don't worry. I have a big file of definitions, commands, whatever. Like usually I have a bash RC. But I don't want to write bash. I want to define my things in Haskell. Even though usually you don't use the Haskell feature, like it's not every day you open your shell and create a gadget, right? No, you don't create a gadget in your shell. But what you do is you run your functions like what do I have? Do I have anything useful? Yeah, I have a bunch of things. I have make virtual. It's just I don't remember the definition, but it just does some things. It creates a virtual make or something. It's defined in Haskell. That's why I do it. I do sometimes when it's more convenient. It's very rare though. I almost never use bash anymore.
Wait, so
Yeah,
so does that mean that you can remove bash from your system?
No.
No.
I mean, everything is bash. So the question was, do you ever use bash? I don't usually use bash. I mean, I can just jump into bash, right? It works, but I don't do it often. In practice, there's no really big difference other than that. I mean, you could just write things in bash and have it be almost the same thing if you could somehow expose. So the really nice thing is, when you want to, when you want to do something that takes an argument. What do I have, for example? I have this. And you can see it takes an array of strings. But this could be an array of anything. And when you want to do things that are more complicated, when you want to have a function that takes complicated input, that doesn't work with bash. You'd have to encode that as a string, and that's the whole point. You could do JSON, but do you want to write JSON in your shell? I don't think so.
What does that GHCI blog function do?
I think it opens GHCI in my blog. I have a blog. I haven't written on it in many months now, but it's because my blog is also Haskell, of course.
Anyone else? No? Okay. Well, thank you, Las.
Thank you
for coming and sharing with us. Where can we find you? Do you have a website you want to share, or?
You can't find me, but I do have a website. It's some people pronounce it lasers. I didn't have this in mind when making the website name, when choosing the domain name. I chose it because it's RS for Rust. I don't like Rust, but a lot of people do that.
Thank you, Las.